So far we know a lot of derivatives and properties for them. Let's look at another class of functions and see if we can look at or find the derivative of those functions. We're going to focus on trig derivatives here first. If we have sine of x, right, how do we find the derivative? Well, let's just use the basic old definition. So that means we need to look at limit as h approaches 0, and then it would be f of x plus h, so it would be sine of x plus h minus f of x, so sine x, all over h. Okay, well, this is kind of interesting. What do? Well, we have to dig back to our pre-calc knowledge and remember, okay, this is angle addition, so we have to use the angle addition formula, which you may remember, otherwise you might need to look up, but we end up getting sine x cosine h plus cosine x sine h, and then this is all minus sine x all over h. Okay, and then what can we do? Well, we can group the things that have sine x in them, right? So this is equal to limit as h goes to 0 of, and then we factor out a sine x, and then we're left with cosine of h minus 1, and then plus cosine x sine h, and then this is all divided by h. Okay. Alrighty, now we're kind of looking at this and we're like, what can we do? And the answer is, well, we can play with algebra even more. And we can write this, again, break this into two pieces, and then remember that our limit is dependent on h, so anything that's not h I can pull out. So this first term I can write as sine x times limit as h goes to 0 of cosine h minus 1 over h, and then plus cosine x, and then limit as h goes to 0 of sine h over h. Okay, now we've about exhausted our tools that we could possibly ever use, and so that's where I'm going to say, voila, some magic happens. No, actually, that we would have to do some further investigation with these limits, look at them graphically, whatnot, or tabularly, and the proof to these identities is in your textbook on those pages. I'm not sure if it's the same thing in the ebook, but they exist in your book. So make sure to refer to those, look through the proofs, see how they do that. But we're just going to use that fact right now, and then I'm going to simplify these. So using this idea, if we look at this first limit as h goes to 0 of cosine h minus 1 over h, well, they use theta, I use h, doesn't much matter, so it's going to be 0, and then plus cosine x, and then sine h over h as h goes to 0. So again, they use theta, I use h, but it's going to be 1, meaning that this whole thing simplifies to x. So if you remember, we had f of x is equal to this, and then all of this was computing the derivative, and so sine x, when we look at that as a function and compute its derivative or differentiate it, we get cosine x. And similarly, we can do the same method, and I'm not going to go through the math. You're welcome to, but we'd have to make use of these limit identities again, but we would show that the derivative of cosine x is negative sine x. So we found derivatives of two trig functions. Can we find more?